Hello mathematicians, hope in this video and getting a little bit of practice you can say I can graph quadratic equations using a table. Let's look at an example here. It says to graph the quadratic equation using a table. Identify the axis of symmetry, vertex, x-intercepts, and y-intercepts. So first of all, let's just go ahead and graph this quadratic equation by filling in this table over here. And when we're filling in these tables, well, we can choose whatever values we want for x. However, it is going to be important that we choose values that are close to the axis of symmetry or close to that vertex, just so that we can graph this quadratic equation appropriately. Because if we just choose any random values, it's not going to give us a good representation of what this graph truly is. So we can choose whatever values we want, but you might need to get a little bit more experience, or as you get more experience, you might be better at picking appropriate values for x. So I'm just going to go ahead. I'm going to start in with just substituting 0 in for x. So if I substitute 0 in for x, well, I'd plug 0 in for x into this equation right here. So we go y equals, I plug 0 in, so 0, and I'll put it in parentheses, 0 squared minus 4 times 0 plus 3. So 0 squared would be 0 minus 4 times 0. Again, that'd be 0. So 0 plus 3, so we just get 3 for y right here. And we could go and we could repeat this process. So let's go ahead and let's plug in 1, and we get y equals, I'll put 1 in parentheses because we're plugging that in for x, 1 squared minus 4 times 1, again substituting 1 in for x right here, plus 3. And we get 1 squared would be 1, minus 4 times 1, and that'd be 4, so 1 minus 4, that'd be negative 3, plus 3, that'd give us 0, so we get 0 right here. Oh, let's go another. So let's go with 2. So that would give us y equals 2 squared. I'm substituting 2 in for x, so 2 squared minus 4, and I'm going to plug 2 in for x there as well, plus 3. Now this one's a little bit more complex. So we get 2 squared, and that's 4, minus 4 times 2, that's 8. So it'd be 4 minus 8, it'd be negative 4, plus 3, so that would give us negative 1. And now we'd substitute 3 in right here, so we get y equals 3 squared. So I'm plugging 3 in for x, so 3 squared minus 4 times 3. And we are adding 3 at the end, plus 3. So it was 3 squared, that's 9, minus 4 times 3, that's 12. So 9 minus 12 is negative 3, plus 3 is 0. So it'd give us 0 right here. And let's go one more value just to get a little bit more data points here. So let's go with 4. So I would go y equals 4 squared. I'll substitute 4 in for x, so 4 squared minus 4 times 4 plus 3 plus 3. So 4 squared is 16, minus 4 times 4, that's 16, so 16 minus 16 is 0 plus 3, so this would give us 3 right here. So I'd say this gives us some good data points right here to graph this equation. So let's go ahead and let's plot these points, and again, this is just each row in this table here is just like a data point, so this would be the point 0, 3, just to clarify. So let's go ahead and let's just plot those points real quick. So 0, 3, so x value is 0 and up 1, 2, 3. So right there would be our point. And 1, 0, so x value of 1, y value of 0. So right there would be that point. 2, negative 1, so 1, 2, and then down 1. 3, 0, so 1, 2, 3, and up 0, so right there. And 4, 3. So 1, 2, 3, 4, and up 1, 2, and 3. So this right here, these would be our points plotted. And now we just go in and we could graph this table right here. So it looks something like this right here. This would be our graph of this equation right here. So now using this graph, we can find out what these other values are for the axis of symmetry, vertex, x-intercepts, and y-intercept. So let's go ahead and do that really quick here. And just one quick thing to mention is that when we are graphing these quadratic equations, this shape right here, we refer to the shape as a parabola. So the quadratic equations, we refer to this graph as a parabola. So when we're asking for the axis of symmetry, what that means is that all parabolas are symmetrical, which means that we can draw a vertical line down the center of this parabola. We could draw a vertical line down this center, and the left side and the right side would be mirror images of each other, so they are symmetrical. So if I were to draw this vertical line right down, if I were to draw a straight vertical line, that is, straight down right here, these two, the left and the right side would be identical to each other. So this is our axis of symmetry right here, and that is at the x value of 2. So that is at the x value of 2. So axis of symmetry is equal to, we could say 2, or I'm going to say x equals 2 just to clarify. So is when x is equal to 2, that is our axis of symmetry. Now it is asking for the vertex. The vertex is the tip of the parabola. So we'd say right here is the vertex. So the vertex is where the x value of that axis of symmetry, that point right there. So this point right here where the parabola meets this axis of symmetry, and the vertex is a point itself. Okay, so it is a point. So this point right here would have an x value of 2 and a y value of -1. So our vertex is going to be the point 2, -1. That would be our vertex. Now it's asking for the x-intercepts, and the x-intercepts are where it intercepts this x-axis. So the x-intercepts would be at this point right here and this point right here. So one has a y value of 0 is another way of saying that. So you can find your x-intercepts algebraically by substituting 0 in for y and then solving for those two x values. Or if we're given a graph right here, or if we graph it out, we just look for where the parabola meets that x-axis. So our x-intercepts in this case would be the points, would be x would be equal to the points, would be 1 and 3. So 1 and 3 would be our x-intercepts. And finally, our y-intercepts. And our y-intercepts is where this parabola meets the y-axis. So that'd be right here, be our y-intercept. So our y-intercept also could be solved algebraically. All we need to do is we'd substitute 0 in for x and then solve for y. Or we can just look for where this parabola intercepts the y-axis. So with that point right there, it'd be 1, 2, 3. So it'd be at the point y equals 3 would be our y-intercept. So that is it for video. Hope after watching this and getting a little bit of practice, you can say, I can graph quadratic equations by using a table.